Hello students, welcome to the My Dream, India's first ever e-learning program. Here, today I am going to discuss electric current and Ohm's law. Electric current and Ohm's law. Now, first of all, you are acquainted with these terms current, voltage, resistance since class 9th and 10th, right? So the definition of current is what? Say electric current is rate of flow of charge. Just this definition is sufficient in itself. It's complete definition in itself. Look, suppose we have a wire, right? Here electrons flow, fine. However, we assume that positive charge is flowing in opposite direction. Still, at some point P, the amount of charge flowing per second is called current. In case of the liquid cells, there are electrodes, cathode, anode, right? And there is flow of ions inside the solution. So there is also flow of charge, which is, and in the external circuit, of course, there is flow of electron through the wire. Internally, there is flow of ions. In both the cases, what thing is common? The charge is flowing, and the rate of flow of charge is defined as current. Even in case of cathode ray tube, we take in air at very low pressure. The ionized air and electrons, they move. In every case, look, ionized air, hydrogen or helium, whatever, and electrons. In every case, actually, what the current is defined, how it is defined, is rate of flow of charge. Simple. So, in general, we write that rate of flow of charge in differential form, we can write dq upon dt. This can happen here, this can happen here, that the rate of flow of charge q is a function of time and space. In these two cases, in general, it may happen, okay? But in case of wires, very soon, the rate of flow of charge q becomes, say I equals to dq upon dt, or I simply say I can be defined as q by t. The rate of flow of charge becomes uniform. So better to deal with the definition. Sometimes we need this, sometimes we need this. This is in case of metals. The rate of, in both cases, the important thing is rate of flow of charge. That is constant. In case of metal wires, and here it can be variable, but the definition is further, its unit, I hope you remember, unit is ampere, but I say I equals to q upon t. 1 ampere is equal to 1 coulomb per second. If through a wire 1 coulomb of charge per second is flowing, then we call that 1 ampere current is flowing through that wire, right? I discuss a very simple question. Suppose I have through any wire, okay, there is 300 microampere current. Question is this: 300 microampere current for 10 milliseconds. The question is, then suppose 300 microampere current is flown for 10 milliseconds, okay? 10 milliseconds, for 10 milliseconds. Now, question is, what is the amount of charge flown, and how many electrons have been flown through? amount of charge to be flown and how many electrons has gone through. Our the definition of current is Q by T. Then I into T equals to Q. So I write Q equals to I into T. Now I write Q is equal to 300 microampere, time is 10 milliseconds. So charge becomes 300 into 10 to the power minus 6, 10 into 10 to the power minus 3. Charge becomes 3 into 10 to the power 2, 3, and here 10 to the power minus 6 coulomb. This amount of charge flows. Now it looks very small charge, but let's see the number of electrons. We know that Q is equal to Ne. Then Q equals to 3 into 10 to the power minus 6 is equal to N 1.6 into 10 to the power minus 19 coulomb. Now if I calculate it, then I get N is approximately 1.9 into 10 to the power 13. It is actually due to this huge number of charge carriers, huge number of electrons. We assume that the flow becomes uniform due to this huge number of. So we can use the definition Q by T. In general, so large number of current flows. I take a large number of electrons flow. I take another example as a good example. In chemistry, you may have studied that electron revolve around the nucleus. Suppose this is the nucleus and an electron is revolving around it, right? The path has radius r, right? The revolving electron forms current. How much current that is? I simply write, if I replace E by Q, okay? If amount of, I am standing here, suppose, okay, at point P. If electron revolves once in a circle, then at point P, I'll observe charge E flowing per second. So current will be E ampere. Charge per second is what? It is current. So rate of flow of charge. Now if the frequency is 2, means it is revolving twice in 1 second. So when I am standing at point P, then I'll see that E will revolve 2 times in 1 second. Then the current will be 2E, 2 into 1.6 into 10 to the power minus 19 ampere. In the same way, if it is the frequency is 50, then charge will look like it is moving 50 times in 1 second. So current will be 50 into. So here the simple definition of current is charge multiplied with frequency. That's all. So in case of chemistry, you can calculate the velocity also, and frequency is 1 upon time period. Frequency is 1 upon time period, and time period is 2 pi r upon v. So frequency becomes v upon 2 pi r, and I equals to qv upon 2 pi r. In this way, we can calculate the current in case of atoms, the current formed by the electrons, the revolving electrons. Now I turn to Ohm's law. There's a definition of current. After that, I turn to Ohm's law. Now, let me tell you Ohm's law. If I ask students Ohm's law, they'll say V is equal to IR. Let me tell you very clearly that this is not Ohm's law. You'll wonder over it, but this is true. This is not Ohm's law. What is Ohm's law? As the electrostatic potential is, electrostatic potential we defined VA to VB, right? If there is VE is higher from B. If I leave a positive charge, then it will move automatically from A to B. I hope you remember the definition. I told you the definition, a charge definition of potential difference. VA minus VB WBA upon Q. Work done to bring a positive charge from B to A is equal to the potential difference. Now, I will have to work if I want to move charge from B to A. Means I will have to work, external work must be done if positive charge is taken from lower potential to higher potential. Now if I leave it at the higher potential, it will come automatically down. It is something like that I am riding something on some hill. I am just taking upward the hill. Then I'll have to work. If I leave it, then it will come by itself. So from here, if I write this potential difference VA minus VB, in general in current electricity this is not written as delta V, it is simply written as V. V means always potential difference, right? It always means potential difference. And if there is any potential difference and charge is free to flow, then the rate of flow of charge is proportionate to the potential difference. This is Ohm's law, not this one. However, when we write the proportionality constant, it is resistance in general for a wire. In case of electrolyte, it can be a different equation, Nernst equation you may have heard. In case of gases, there could not be Ohm's law. That means the current, the flow of charge, amount of flow of charge may not be proportionate to the value of I proportionate to 1. Even in case of gases, sometimes we have the V proportionate to I raised to power 3 by 2. Later in the semiconductors you will study this, but it may happen. So that is not Ohm's law, but this is Ohm's law. Now in general, in wires, in case of wires, the proportionality constant is R, which is called the electrical resistance. So from here we define resistance also. So resistance is what? V upon I, means volt upon ampere, and unit of resistance is ohm. Very simple, right? If we want to write the dimension of resistance, then we need to write V upon I, dimension of all this, W upon Q upon Q upon T. W upon Q square T. So dimension of R. Dimension of work is equal to dimension of energy, M1 L2 T minus 2 T1 upon Q2. So the dimension formula becomes M1 L2 T minus 1 Q minus 2. Got it? This is the dimension formula of resistance. Further, there is one quantity which is usually, sometimes it is used, inverse of resistance is called conductance. R is what? Resistance. G, which is 1 upon R, is called conductance. Okay. Further, there will be two terms, resistivity and conductivity. Those are different. Resistance and conductance, these two are different things. Okay. Well, now I discuss a little bit about resistance. Suppose here, first of all, I'll make it clear that here I am talking about the metal wires only. Okay, the resistance. I have a wire of length L and its cross section area A. Then by experiments it can be easily shown if we increase the length. We increase the length, then for the same voltage current gets reduced. That means resistance is increasing. So resistance is proportionate to length. At the same time, a thicker wire, we have more current, means resistance is lesser. So R is inversely proportionate to the area. Second point. So if I collect these two, R proportionate to L upon A. And now I want to make this proportionality equality, then I'll use a constant rho. This constant rho is called resistivity. Let me tell you, and again, inverse of 1 upon rho sigma, it is conductivity. So this formula can also be written as R equals to L upon sigma A. These are just symbols. You just need to get introduced with them, and then you must get acquainted with it. Now I take a simple example of it. For example, we have a wire of length L. Question is that if it is stretched to double its length, right? Then what will be the presently the resistances are. If it is stretched double to its length, then what will be the new resistance of the wire? Now let's solve it. R equals to rho L upon A. Now if we double its length, okay, then its length will become 2L. Previously the area was A, and the now area will become A by 4. Why? Because volume must remain constant in both the cases. The volume must remain constant. So here the volume is AL, and here the volume will be 2L into, this should be A by 2, sorry, it's A by 2. Now what will be the new resistance? R dash rho L is 2L and area is A by 2. So R dash equals to 4 rho L upon A. So R dash becomes 4 times of the previous resistance. It's a very common question, which has been very common to multiple exams. Discuss another question. Suppose I have a wire of length some L, cross section area A, similar way, okay. Now it is made threefold or twofold. For example, it is made in this way. Its resistance is R and cross section area is A. It is made in this way. It is made in this way. Now, what will be the new resistance? R is equal to rho L upon A. In this case, the area becomes 2A and length becomes L by 2. I hope now it is very clear. Then R dash is equal to rho L is L by 2, area is 2A, and R dash equals to rho L upon 4a, then R dash becomes 1/4 of the previous resistance, right? This is the simple thing about the current, resistance and Ohm's law, right?